Hello, this is Algebra topic 6-4 on the differences of squares. So we're going to be factoring, but we're going to be factoring using a rule called the difference of squares. So first let's talk about what a perfect square is. A perfect square is a product of a number times itself. So some perfect squares would be 1, because 1 times 1 is 1. 4, because 2 times 2 is 4. 9, because 3 times 3 is 9. 16, because 4 times 4 is 16. 25, because 5 times 5 is 25. We also have some others. X squared, x to the 4th, x to the 6th. This is x times x squared times x squared, and x to the 3rd times x to the 3rd. We can also use fractions. 1 over 4, that would be 1/2 times 1/2. 1 over 9, 1/3 times 1/3. 1 over 16, 1/4 times 1/4. And so all of these make perfect squares. Now in order to do these, we're going to need to do perfect squares, but first, let's go ahead and see what we have. Well, a squared minus 1, that's the same thing as saying a squared plus 0a minus 1. So our first term goes here. Our last term goes here. We want a sum of 0a and a product of negative 1. So what multiplies to 1 and gives us negative 1? Well, that would be positive 1 and negative 1. If we add those up, we get 0. So we have 1a and minus 1a. The only way to get a squared is to do a times a. A times 1 gives us 1a, and a times negative 1 gives us negative 1a. And negative 1 times 1 is negative 1. So here we have a plus 1 and a minus 1. Let's go ahead and take a look at number 3. This is the same thing as saying 9b squared plus 0b minus 4. So 9b squared goes here, minus 4 goes there. We want a sum of 0 and a product of 36. It needs to be negative 36. So what multiplies to negative 36 and gives us 0? Well, that would be 6, and negative 6 will give us 0. So we have 6b minus 6b. And let's take a look. Well, to get 9b squared, I can do 3b times 3b. And 3 times 2 gives me 6. And 3 times negative 2 will give me negative 6. So here I have 3b plus 2 and 3b minus 2. So that's what we've got. And we want to see if we can see a pattern. Well, here's the pattern. The square root of a squared is a. And the square root of 1 is 1. And so we have a plus 1 and a minus 1. The square root of 9b squared would be 3b. And the square root of 4 would be 2. So we have 3b plus 2 and 3b minus 2. So our pattern is that we square root the first term and last term, then it's the square root of the first plus the square root of the second, and then the square root of the first minus the square root of the second. Let's go ahead and put this into action. So if we take a look at this, well, the square root of x squared is x. The square root of 9 is 3. So it's x plus 3, x minus 3. Very simple. The square root of d squared is d. The square root of 121 is 11. And so it's d plus 11. D minus 11. Go ahead and pause the video, see if you can answer any of these, and then start it back up again to double check. I'm going to go ahead and continue working on these, and I want to see if you actually understand how to do this. It's very simple. The square root of 100h squared would be 10h. The square root of 81 would be 9. So it's 10h plus 9. 10h minus 9. Now, if this is minus and this is plus, it's okay. You can swap these two signs and it'll still be the same. Let's go ahead and jump to number 7. That would be 5k and 8j. So looking at 5k minus 8j and 5k plus 8j. Again, this could be plus and that could be minus. It really doesn't matter. Just whatever fancies your mood. Notice that k squared was k and j squared was j. Moving on to number 8. 4z squared would be 2z. 9a squared would be 3a. So we have 2z plus 3a. 2z minus 3a. On number 9, this is not a perfect square. Neither is that. And so, that is as simple as we get, which we're going to label this as prime. Looking down at number 10, this is a perfect square, and so is this, but that's a plus sign. Because it's a plus sign, we can't do it. So this one is also prime. And now for our last example, number 11. 1/9 actually is a perfect square. That would be 1/3 c. 64 would be 8d. And so it's 1/3 c plus 8d and 1/3 c minus 8d. And so that's how you do difference of squares. Now, you do have to make sure that they are perfect squares, unlike number 9. And you do have to make sure that you are subtracting, unlike number 10. But don't let fractions throw you off, because 9 is a perfect square. This is actually 1/3. So, hope this is as easy for you as I think it will be. Have a good day, and good luck on your assignment.